Here is today's pre-calculus homework, section 3.3, day 1. We are to graph these different types of parabolas in different forms. Let's review. Here's problem number 1 for your homework. This is a quadratic equation. It's a parabola. It's in this is called transformation form. Another name for transformation is vertex form. What we know about this is because the A value is positive, this is up. It's not down. And since it's up, our graph is going to look like a U, and our vertex is going to be our lowest point, so it's a minimum. We do not have a max. Now, the easiest thing for us to find is the axis of symmetry, which is the opposite of this number. It's x equals 5, and our vertex is 5, 2. Our domain is all real numbers all the time for these, and our range, since this is a U-shaped parabola, and our lowest point is 5, -2, our range is going to be y is greater than or equal to this number right here, 2. How do you find the x-intercepts? The x-intercept, you plug a 0 in. Plug a 0 in for y. And I'm going to do it on a separate sheet because it gets long. If I put a 0 here, you have 3 times x minus 5 squared plus 2 equals 0. If you were to subtract 2 and divide by 3, you end up getting -2/3. And when you take the square root of this, you have a negative here, so there are no x-intercepts. The y-intercept is when x is 0. When you put a 0 here, what is 0 minus 5? It's -5. -5, so you have 3 times 0 minus 5, square that, and then add 2. So you have 25 here, -5 squared is 25. 25 times 3 is 75, plus 2 is 77. So your y-intercept is 0.77. Obviously, it's off the page. So how do you graph this? Well, let's start with our axis of symmetry is x equals 5. Right there. And we're going to plug 5, 2. That's our vertex. It's our lowest point. And our graph is going to be shaped this way, which makes sense that it's never going to hit the x-axis. So now, how do you find, we don't have any other points. Our y-intercept is 0.77. It's way up here. So we need a few other points here. So your best bet is to plug in numbers to the left of 5. So, for example, you would plug in 4. And then I would plug in a 3, a 2, or a 1. Now, you only need 5 points. If we plugged in a 1, 1 is probably going to be really high up, because if 0.77 is our y-intercept, I'm thinking that if we put a 1 here, which, yeah, 1 minus 5 is -4. So let's do 1. You have minus 5 is -4. -4 squared is 16. And 16 times 3, that's too big. So let's try 2. That's too big. Try 2. If we put a 2 here, 2 minus 5 is -3. -3 squared is 9. 9 times 3 is 27. 27, that's a little too big also. So that's too big. Let's try 3. 3 minus 5 is -2. -2 squared is 4. 4 times 3 is 12. 12 plus 2 is 14. So we have, that's good enough. We're going to do 3, 14. So 3, I believe this is 12. So we have 13, 14. And then we can go the other way too, and we're going to go up 14. And then I would do 4. Plug a 4 in here. 4 minus 5 is -1. -1 squared is 1. 1 times 3 is 3. And 3 plus 2 is 5. So we have 4, 5. So 4, 1, 2, 3, 4, 5, and then we can go 5 this way. And there's our graph. Now, how could we turn this into polynomial form? You would square this, multiply it by 3, and then add 2. That's what we're going to do tomorrow. Number 2, another example. This has a negative in front, so that means it's down. It's shaped this way. So our vertex is our max. What is our axis of symmetry? It's x equals 1. Our vertex is 1, 2. Our domain is always all real numbers, and our range, since this is going to be upside down, and 2 is our biggest, that's going to be our biggest number, so it's y is less than or equal to 2. So let's start. Our x is equal to 1 is our axis of symmetry. 1, 2 is our vertex, so this is going to be upside down. It will hit the x-axis. Where? So if you plug a 0 in here, you've got negative 1 times x minus 1 squared plus 2. Set this equal to 0. So if you subtract 2 and divide by negative 1, you get x minus 1 squared equals a 2. Negative 2 divided by negative 1 is 2. Then you square root these, and you get x minus 1 is equal to plus or minus the square root of 2. And then add 1. These are the two places where the graph hits the x-axis. Now, because they are, we have radicals, we want to convert this to decimals, or estimate them. So here's my calculator. How do I do this? I'm going to convert 1 plus the square root of 2, because I want to see where it's hitting the x-axis when I graph this. So 1 plus the square root of 2 is about 2.4, and 1 minus the square root of 2 is about negative 0.41. So where we have, these are the two x-intercepts with their exact form, but if you want to write 2.4 comma 0 and negative 0.4 comma 0, that's estimated. So where are these 2 points? So over 2.4, about here, 1, 2, about there, and 0.4 is about, negative 0.4 is about there. Your y-intercept, where is this thing hitting the y-axis? If you plug a 0 in for y, 0 minus 1 is negative 1, negative 1 squared is 1, and 1 times negative 1 is negative 1, negative 1 plus 2 is 1. So 0, 1 is your y-intercept right there, 0, 1. And you could also plug a point I should probably move this over. The graph is not the greatest, but move that over a little bit. You can plug this point in. It's symmetrical, so it's going to go 1 unit over. And if you want to plug in any other points, I would possibly maybe try a -2 or a -3. I would do a -2. I'm sorry, a -1 or a -2. So if you wanted to do -1 or -2 into this, let's try -1. If you want to plug a -1 here, -1 minus 1 is -2. -2 squared is 4. 4 times -1 is -4. And -4 plus 2 is -2. So over 1 and then down 2. And you can go there also. And that's enough. 5 points is sufficient. We have more than 5. Okay? The next two are looking at polynomial form. In polynomial form, another name for this is standard form. You want to look at the a value. In this case, oops, that's the example. This is the homework problem. The a value is 1. If it's positive, it's up. So this is not down. And because it's going to be u, like that. Our vertex is going to be our minimum, not our maximum. Now what's nice about this, besides the A value telling us if it's up or down, and then if we have a max or a min, this is very important, and that's our y-intercept. So 0, 3 is where this graph is hitting the y-axis. The rest of it we have to do some work. Our axis of symmetry is found by x is equal to negative b over 2a, our formula. So it's the opposite of negative 6, which is 6 over 2, and the a value is 1. So 6 over 2 is 3. X equals 3 is our axis of symmetry. Then what you have to do is plug 3 into this equation and do 3 squared minus 6 times 3 and then plus 3. So you get 9 minus 18 and then plus 3. 9 minus 18 is negative 9, and negative 9 plus 3 is negative 6. So 3, negative 6 is your vertex. So let's plot these. So 3 is our axis of symmetry, x equals 3. And we have 3, negative 6, 1, 2, 3, 4, 5, 6. That's our vertex. And our y-intercept is 0, 3. So I know I can go 3 units this way also. So far I have 3 points. I need 2 more to have a nice graph. Our domain and our range, all real numbers is our domain. And our range, since this is our lowest point, 3, negative 6, and it's going up, our range is y is greater than or equal to negative 6. How do you find the x-intercepts? Well, you plug a 0 in for y, and you have this problem, x squared minus 6x plus 3 equals 0. Since this is not factorable, we need to rely on what we reviewed in chapter 2 to solve for x. Since this has an even middle term, I would complete the square. I'm going to subtract 3. Take half of that, which is negative 3, and square it. You're going to get a 9 here and a 9 here. Factor, and then square root. Again, we're going to see that our x-intercepts are not nice integers. So what are the x-intercepts? It's 3 plus or minus the square root of 6. Again, we're going to want to convert these. This is when you're going to want to convert 3 plus the square root of 6 is about 5.4. So we have 5.4, and 3 minus the square root of 6 is about 0.55 or 0.6. Those are your 2 x-intercepts, and I just found them by converting the 3 plus root 6 and 3 minus root 6. So let's plot those points, and we get 3, 4, 5 about there, and right about here, 0.5. And it should be pretty symmetrical. Now what if I want more? I have 5 points, it's good enough. What I would do is, if I want to see if I'm not sure how to connect these 2 dots, I'm going to probably want to plug a 2 in. If I plugged a 2 in, here's 1, here's 2, x is 2, I'm going to use my T-chart, and I will plug 2 in here, and it shouldn't be that bad. 2 squared is 4, negative 6 times 2 is negative 12, and then plus 3. So you end up getting negative 8 plus 3 is, this is 8, negative 8 plus 3 is negative 5. So 2, negative 5. So over 2, down 1, 2, 3, 4, and we were right on, right there. That's a nice graph. Okay, again, here we go. Number 4, same thing. This has a positive 1 for the A value, so this is up. So that means our minimum is our vertex. Okay, so it's looking like this. Our minimum is our vertex. Our domain is all real numbers. Our y-intercept is this lovely number here, 0, negative 1. The rest we have to do a little bit of work. How do you find the axis of symmetry? It is x equals negative b over 2a. So it's negative 8 over 2 times 1, so it's negative 4. X is negative 4. our vertex is going to be -4. You're going to plug -4 in here. So it's -4 squared, so that's 16. 8 times -4, which is -32, and then -1. So it's -16 minus 1 is -17. That's a little off the page. What's our range? Because this is a U-shaped, it's going to be y is greater than or equal to -17. How do you find the x-intercepts? Well, you're going to plug a 0 in for y, and again, you're going to solve x squared plus 8x minus 1 equals 0. I would add 1 and take half of that, which is 4, and square it. You get 16. You're going to add 16 to both sides, and you're going to factor square root of both sides. So you get x plus 4 is equal to plus or minus root 17. So your x-intercepts in exact form are -4 plus or minus root 17. But you're going to want to, again, estimate them. So what is -4 plus the square root of 17? That's about 0.12. And -4 minus the square root of 17 is about -8.12. So let's put all this together. Our -4 is our axis of symmetry. Okay. 0, -1 is our y-intercept. So we have that point, and we can go 4 units across this way. And we're going to pretend like that's 0, we're going to pretend like that's -4, -17. And where is it hitting the x-axis? We said it's 0.12, so just right there. And -8.12, which is, this is 7, and that's 8. 4, 8, I'm sorry, 8 and a little bit more, so 8.12. Now, this is kind of a strange looking graph. So what I would do, it's on target here, but what I would do is I would plug in a number, like let's say this number here, -2. If you plugged -2 in here, -2 squared is 4. I'm going to just do it right down here. 8 times -2 is -16, and then -1. So you have -12 minus 1 is -13. Okay? So that's -12 minus 1 is -13. So if you go over 2, you would go down 13, which is right about there, and you can go that equal distance. It just makes it nicer to connect the dots, just like that. Okay? Next, the last two, these are called x-intercept form. And what's nice about them is the number in front is your A value. I don't see a number there, so it's an understood 1. It's positive, so it's up, which means we're going to have a minimum again. What we like, remember, domain is always all real numbers. What's nice about this form, we have the 2 x-intercepts. The x-intercepts are going to be 2, 0, and -3, 0. The rest we don't know. So we have 2, 0, we have 2, 0, and we have -3, 1, 2, 3, 0. So, how do we find everything else? Well, what you're going to have to do is either split the difference between these two. So if you split the difference, you'd get x is equal to -1/2, which is right in the middle there. So your axis of symmetry is x equals -1/2. The other way you can find that axis of symmetry is you would have to FOIL this. You would have to square x times x is x squared, and then add 3x minus 2x is 1x, and then -6. Then from here, what I would do is I would use now it's in polynomial form, do -b over 2a. So what is the b value? It's 1, so it's -1 over 2 times 1, which is 2, and that's where you get -1/2. Now how do you find the vertex? you're gonna have to plug -1/2. You can plug it in here, or you could do it here. If you like this, you can do it there. Okay, let's do it here. -1/2 squared is 1/4. And then -1/2 times 1 is -1/2. And then -6. So we've got, you can convert these to decimals if you want. So 0.25 minus 0.5 minus 6. So we have 0.25 minus 0.5 and then minus 6. It's -6.25. So -1/2 comma -6.25. So sometimes they don't turn out as nice as we want them to. So over 1/2 and down 6.25. 1, 2, 3, 4, 5, 6, and then a little bit more. Now, since we converted it to polynomial form, this is our y-intercept, so 0, -6. So that's one reason that you would want to convert from, that's what we're going to talk about tomorrow, converting it from x-intercept form to polynomial form. You get the vertex easy. Otherwise, you have to plug a 0 in. So right here is your, and you'd want to go equal distance across. That's your y-intercept. And now, if you want any other points, which we're fine, you can just connect the dots, or you can just plug in a number. Like, I would plug in -2, or you could plug in 1. 1 would be an easy one to plug. If you plugged a 1 in here, 1 squared is 1. 1 times 1 is 1. 1 plus 1 is 2. So you'd get -4. So over 1, down 1, 2, 3, 4. Probably could have bent it a little bit more. 1, 2, 3. 1, 2, 3, 4 right there. And then same with, you go equal distance across. So right here at -4. It just makes it more complete the more points you have. And the last graph, this is down. How do I know? Because it's a -2. It's looking like this. So now our vertex is our maximum. We don't know the axis of symmetry. We don't know the vertex. We don't know the range yet. We do know the domain is all real numbers. And our x-intercepts would be -3, 0, and -1, 0. So let's plot those. -3, 0, and -1. -1, -2, -3. Okay, so this is fairly easy. We can split that. Our axis of symmetry would be the line x equals -2. Okay, now if you don't know that, what you could do is FOIL this out. If you FOIL this out, you get x squared plus 4x plus 3, and then multiply this all by -2. You get -2x squared minus 8x minus 6, and then do -b over 2a. So 8 over -2, 2 times -2, so you get 8 over -4, which is -2. You could do it that way. Now, how would you find the vertex? You're going to plug -2. Now, you could plug it in here. You might want to do it in this way. It's a lot easier. So if you plugged a -2 here, you've got -2 times -2 plus 3 is 1, and -2 plus 1 is -1. So if you multiply these, you get 2. So -2 comma 2. That's your vertex. So over 2 and down 1, 2. That's your vertex. Now your range, since it's going to be upside down, we have something wrong here. -2, 2. I graphed that wrong. -2, 2 is right there. So what I did was I looked at my picture, I looked at the up and down, and I saw that that was not correct. So I plotted my vertex wrong. Now we said that the y-intercept is going to be this number that's out here by itself, so 0, comma, -6. If you don't have it in vertex, in polynomial form, what you could do is plug a 0 here and here and solve for y. You'll get -6. So 0, -6, 1, 2, 3, 4, 5, 6. And then you can go 2 units the other way, and then connect your dots. And the last thing we didn't do is state the range. the range, since it's upside down and that's your y value, it's gonna be less than or equal to 2. And here is a picture of what you should have. We are done.